Find the sum to n terms of the following series. Let us begin. So here we have a series with first term being 2, followed by the next term which is 4. Then we have 7, then 11, and then 16, and we have the rest of the terms. Now clearly, this is not an arithmetic series, for it does not have any common difference. Also, it's not a geometric series because there is no common ratio here. But we can see a pattern here. So let's say we consider the second term of the series, which is 4, and from it subtract the first term, so that's 2. 4 minus 2, that's going to give us 2. Coming to the third term of the series, that's 7. From here, we subtract the second term, 4, so that's going to give us 3. Then we take the fourth term, subtract the third term from it, giving us 4. And then we do 16 minus 11, so that's going to give us 5. Now here we can observe that 2, 3, 4, 5. Clearly, the next number in the sequence is going to be 6. Now clearly these numbers are forming an arithmetic sequence. So that means they are going to be in arithmetic progression with a fixed common difference of 1. Fine. So what we have done here, we have taken the difference. So this is going to be referred to as the method of difference, which we'll be employing to find out the sum of the given series to n terms. So what we'll do, we'll suppose that let Sn represents the sum to n terms of the given series, with the last term being Tn. We're also going to consider the second last term of the series. That's simply denoted by take t and replace the n, the index n, with n minus 1. Fine. Now what we'll do, we'll take the same sum again. Then we have the first term, which is 2, but we're going to write it below the second term of the first sum. Then we go to the next term of the series, which is 4, but we are going to write it below the third term of the first series. Similarly, we have 7, then we have 11, and this keeps on continuing all the way up to the second last term, which will be simply Tn minus 1 followed by Tn. Okay, now what we'll do, we're going to perform a subtraction here. Now, on the left hand side, Sn minus Sn, that's simply going to go to 0. Fine. Now here, we have 2, so there is no term here. This is simply 0 actually. So 2 minus 0, that's going to be 2. Add it to, so 4 minus 2, that's going to give us 2. 7 minus 4, that's 3. 11 minus 7, so that's 4. 16 minus 11, so that's going to be 5. So this is going to continue. Now we have Tn minus Tn minus 1. Now we are left with the last term of the second series, so we are going to get negative Tn. So what we'll do, we'll transpose this Tn to the left hand side such that we get Tn equals to 2 added to 2 plus 3 plus 4 plus 5 all the way up to the last term, which is denoted by Tn minus Tn minus 1. Fine. So we have the nth term of the series. Now what we'll do, we'll try to simplify this series. Simplifying means we'll try to find out the general term. So here, let's keep the first term as it is, so that's 2. Now from the second term onwards all the way up to the last term, so this is going to be the last term, Tn minus 1. So this particular series is an arithmetic progression. That means it's an arithmetic series whose first term is, let's write down the first term a, that's equals to 2. The common difference d, that's simply going to be equals to 1. And then we have the nth, we have the number of terms. So here we have to be careful with the number of terms of the arithmetic series. So here the number of terms is going to be equals to not n but n minus 1. Let's try to understand it why this is the case. For the first sum, what we do, we excluded the first term, that is 2. We included the second term all the way up to the last term, Tn. Now by definition, Sn is going to have n number of terms. The moment we exclude one of the term from the series, it's going to be left with only n minus 1 number of terms. Similarly for the second sum, so here let's not consider the 0, this is only added for our convenience. So here the first term was 2, so we included the first term in this case and went all the way up to the second last term. So here we didn't consider the last term, that is Tn. So that means we also have an n minus 1 number of terms. Now during subtraction, we took n minus 1 number of terms from the first sum Sn, and from here subtracted n minus 1 terms of the second sum. So that means this is going to leave us with n minus 1 number of terms. So that's the reason it has n minus 1 number of terms and not n. And we know what is the sum to n terms of any general arithmetic series. The sum to n terms of any general arithmetic series is given by the number of terms divided by 2, multiplied to 2 times the first term, added to n minus 1, the total number of terms, minus 1 times the common difference t. So we'll use this particular formula here. So we have n, we need n over 2, but in our case, we have total of n minus 1 number of terms. So we are going to replace this index n with n minus 1. So n minus 1 divided by 2. This will get multiplied to 2 times the first term. So our first term, that's 2, added to, we need n minus 1 here. So we have n minus 1 minus 1 multiplied to the common difference, so that's 1. Let's further simplify. We're going to get 2 added to n minus 1. So we have 2 times 2, that's 4, added to n minus 2. So that's going to give us n plus 2 whole divided by 2. We can further combine these two terms. So we have a common denominator of 2. So after simplification, we should get n squared plus n plus 2. So this is going to be the nth term of the series. Now we have successfully obtained the nth term of the series. Now that we have the nth term of the series, we are ready to find out the sum to n terms. Now to find out the sum to n terms of the series, all we have to do is take the summation of the general term or the nth term of the series. All we have to do is replace the index n with k. So here k is going to run from 1 to the last term, which is n. This is going to be equals to summation. So here what we can do, in place of tk, we can replace it with k squared plus k plus 2 whole divided by 2, where our index k runs from 1 to n. We can further simplify this. Now here 1 over 2, that's a constant. We can pull it out of the summation sign. So we have half multiplied to the summation of k squared, where k goes from 1 to n. Coming to the second summation, we'll again take half as the common factor. So we have half multiplied to summation of k, with k running from 1 to n, added to. Next we have 2 over 2 times summation of 1 with k running from 1 to n. Okay. Furthermore, we have now half times summation of k squared. What is summation of k squared? That's simply 1 squared plus 2 squared all the way up to n squared. This is the sum of the squares of the first n natural numbers. Then we have half multiplied to summation of k. So when we extend the summation, this is simply 1 plus 2 all the way up to n. So that means this is the sum of the first n natural numbers. Then we have the third sum. So 2 over 2, that's simply 1. Now summation of 1 means we have 1 plus 1 added to itself n number of times. Okay. Now we have a general formula for finding out the sum of the squares of first n natural numbers. So we already have the half here. So half is going to get multiplied to, there's a standard formula which is given by n times n plus 1 multiplied to 2n plus 1 whole divided by 6, added to, we have half multiplied to the sum of the first n natural numbers, that is simply given by n times n plus 1 whole divided by 2, added to, now we have 1 plus 1, so 1 is getting added to itself n number of times, so this is simply 1 multiplied to n. So this is going to be the sum to n terms. So what we'll do, we'll combine all the three terms. Now this is a very simple algebra which I'm leaving as an exercise for you to try out, and this should finally give us n over 6 multiplied to n squared plus 3n added to 8. So this is going to be the sum to n terms of our given series, 2 plus 4 plus 7 plus 11 plus 16.